Hello everyone, this is Aditya and today we're going to study range. So let's start the lecture, but for that please do like, share, subscribe my channel and please support video. Now let's start. So in this lecture we will see different kind of questions to understand range, and I will give you a brief idea about range, that what is it and what is it all about. So basically if I say y is equal to some function of x, right? So in this, when we say x belongs to some set A, then A is called as the domain, right? So suppose A contains the values as suppose x1, x2, x3. Suppose three values it has, right? So when you say y is equal to fx, and when you substitute these values, you will get y is equal to fx1, right? F of x1, right? Y1, and y2 is f of x2, y3 is f of x3, right? So y1, y2, y3 are called as range. So y belongs to y1, y2 and y3, right? Correct. So this is called as the range. So basically range is the different values which can be taken by y, right? Okay. So let me raise this and let's see the questions. Okay. So let's see first of all this simple question. So let's see how we'll solve it, right? So y is equal to 1 upon x minus 1, right? This is the question. Okay. So what we do in this is that instead of writing y is equal to f of x, we will write x is equal to some g of y, right? So let me tell you how. Since y is equal to 1 by x minus 1, so we will have y into x minus 1 is equal to 1, correct? Right? So we'll have x minus 1 is equal to 1 upon y. Hence x is equal to 1 upon y plus 1, correct? Now we know that the denominator can never be 0, or instead of this you can say x is equal to 1 plus y by y, right? Okay. So we know that denominator can never be 0, which means that y cannot be 0. Hence we get the value of y as y belongs to real numbers minus 0. So 0 is not included in this, right? Understood? Right. So I hope that you understood this. So basically what we do in this is that we first of all write the function in terms of x, and then we will get x is equal to some function of y, and then we apply the same rule as we applied in domain, that we need to check for the denominator, we need to check for other expressions which we will see later, right? So I hope so that you understood this. So in this case the range is this is the range, right? Okay. Now let's see this question. So it states that y is equal to x square minus 1, x square plus 1, right? So again you have to write it in terms of f of y, right? So we get y times x square plus 1 is equal to x square minus 1, correct? Okay. So y x square plus y is equal to x square minus 1. So you can bring there. So you have y x square minus x square plus y plus 1 is equal to 0, right? So you have x square into the quantity y minus 1 is equal to negative 1 negative y. So you have x square is equal to 1, I mean negative 1 negative y by y minus 1, correct? Correct expression, right? Now we know that x square is always greater than equal to 0, correct? Which implies that negative 1 negative y by y minus 1 is always greater than equal to 0, right? Okay. And we can say that y plus 1 y minus 1 will be less than equal to 0. Now it is just a simple wavy curve which you need to apply. So let me tell you that also, negative 1 and 1 over here, right? Okay. So when y is greater than 1, so this region will be positive, and of course this region will also be positive, this region will be negative. Now in this, y cannot be equal to 1 because in that case denominator will become 0. Hence we'll have y belongs to negative 1 to 1. That is the answer, correct? Okay. Now let's see this question. Okay, I hope so that you are understanding everything, right? It is just a basic video so that you can understand all different types of concepts. Okay, so y is equal to this expression, right? Now there are multiple methods to solve this, so I will tell you few, right? So first of all, let's see this method. Now we know that sine x lies between -1 to 1, correct? Right. So 2 times sine will lie between this expression, correct? Right? And when you add both sides 1, you will get -1, 2 sine x plus 1 less than 3, correct? And this what? This is equal to y. Hence, y belongs to -1 to 3, correct? Right. Okay. And suppose if the question was suppose sine square x plus sine x plus 1. So of course you can't apply this method over here. So how you will do this? Then in this case what you will do is that let me tell you from this example only, y is equal to 2 sine x plus 1. So y is equal to 2 sine x plus 1. So you will say y minus 1 by 2 is equal to sine x, correct? You solve for sine x, and then you know that sine x lies between -1 to 1, which implies that y minus 1 by 2 will also lie between this expression, correct? Hence this expression y minus 1 by 2, this, correct? So you will have -1 is less than equal to y is less than equal to 3. So again got this expression. So in this case also you will solve for sine x. So you will get sine x is equal to some function of y, and then you will use this concept, right? Understood? Okay, so now let's move to the next question. So now this is this question. So again we will apply the same rule that sine x lies between -1 to this expression, right? We multiply by -2, so you will get 2 less than equal to -2 sine x greater than equal to -2, correct? Correct expression, right? Now let's add both sides. 3, what you will get? 5 less than greater than equal to 3 minus 2 sine x greater than equal to, when you add 3 you will get 1, right? Okay. And when you take the reciprocal, what you will get? 1 by 5. The inequality will reverse, correct? Right? Okay. Is less than equal to 1, right? Okay. And then you multiply by 2 both sides. You will get 2 by 5 is less than equal to 2 by 3 minus 2 sine x less than equal to 2, right? Correct? And this is what? Y belongs to 2 by 5 to 2, correct? Correct expression? Right. Okay. So I hope so that you are understanding the basic idea that how do we find the range and all, right? Okay. So basically the basic idea is that you write f of x, y is equal to f of x as x is equal to g of y, and then you apply the concept of domain which you are applying in y also, right? So basically that is the range. Okay. So basically that is the idea. Okay. And also that if you practice all these questions, your concepts of range will become very strong. So don't worry about it. Okay. Now let's see this question. Now again this is the same thing. We know that this is fraction part of x. So fraction part of x is always lying between 0 and 1, and 0 is inclusive, right? So again you just multiply by -2, you will get 0, and of course if you are multiplying by negative, so the inequality will reverse. So -2, this expression is greater than -2, correct? When you add 3 you will get this expression to this, and this is 1, correct? And then you take the reciprocal, you will get this expression 1 by 3 minus 2 fractional part of x and 1, correct? And you multiply by 2, you will get 2 by 3, this expression 2 by 3 minus 2, this function x, and you will get y belongs to 2 by 3 to 2, correct? This is exclusive, this is inclusive, this is exclusive. Okay, correct? After that it is simple and you can do it, right? Okay, so let me discuss the next question. Yeah, so before discussing this, let me discuss 8th question. Yeah, so y is equal to root x. So let me define you over here. Y is equal to root x. So if I say x is equal to -1, then y is equal to root of -1. Is it defined? I'm not talking about the complex number or imaginary numbers over here. Of course it is not defined in real axis, of course. If I say x is equal to 0, yeah, it is defined. X is equal to 1, it is defined. So x belonging to the positive real number union 0, or x belonging to, yeah, you can say it like this also, right? So why I've taken real positive union 0? Because in some books they take real positive as exclusive of 0, and in some books they take inclusive of 0. So that is why for safety purpose I have written union 0. Okay, right. So x belongs to this value. So we know that y is equal to root x, right? Now since x belongs to this expression, right, real positive union 0, so of course when you take the square root you will get y belongs to real positive union 0 only, right? Correct expression. Is it correct? Yeah, it is. And yeah, many people get confused that if I write y square is equal to x, then also it will have the same result. Of course, no. Why? Because it implies y is equal to plus minus root x. Remember this. So in this case, y will be belonging to real numbers. But over here, y will be belonging to this only. Why? Because here it is only positive x. So don't get confused. When I say root 4, it is equal to, not root 4 is not equal to negative 2. Remember this, okay? But yeah, if I say, let me tell you one more thing over here. If I say x square is equal to 4, then that case x will be equal to plus minus 2. But if I say x is equal to root 4, then x will be equal to only 2. This is the difference. You should remember this, okay? So after that, now it is clear. So now let's see that question number, this expression. Yeah. So now we have this expression. So we know that x square is always greater than equal to 0. Correct? Hence x square plus 4 is always greater than equal to 0 plus 4. Hence x square plus 4 is always greater than equal to 4. When you take the square root, you have x square plus y plus 4 greater than equal to 2. Okay, now I took square root over here. Why did not I put plus my sign? Because here it is only positive sign. There is no negative sign. Remember this, right? Okay. So this expression is always greater than 2. Hence y is always greater than 2. Hence y belongs to 2 to infinity. Okay. So now let's see the next question. We have done this. Okay. Now let's see this one. Okay. So it is a quadratic expression. You know it. So if you must have studied quadratic or you must have studied calculus, you can easily understand this. So it is an upward facing parabola. So it looks like this, correct? And yeah, somewhat like this. Let me draw it properly. So it looks like this. Wait, what I'm drawing? Yeah. So it looks like this, right? Okay. So you know that this point is negative b by 2a comma negative d by 4a, right? Okay. Now this is the point of, this is minima, correct? Okay. Now either you apply this formula or you apply calculus. Basically y is equal to x square plus x plus 1. You just differentiate this expression dy by dx. You will get 2x plus 1 and set it equal to 0. You will get x is equal to negative 1 by 2. So you will get y is equal to negative 1 by 2 whole square minus 1 by 2 plus 1. So you'll get 1 by 4 minus 1 by 2 plus 1. So you will get this expression as negative 1 by 4 plus 1, which is equal to 3 by 4. So this is this point. So negative b by 2a is basically negative 1 by 2 and negative d by 4a is 3 by 4. Hence y belongs from 3 by 4 to infinity, correct? So this was one method. Basically let me explain this one. Okay, so basically this was our function y is equal to f of x. So this point we know that it is the point of minima, right? So to find minima, we find the derivative, we find the critical point. So when you take its derivative, you get 2x plus 1 is equal to 0. You set it equal to 0 to find the critical point, correct? So from this you will get x is equal to negative 1 by 2. So this is the abscissa value or the x value of this point. And when you substitute back in this y is equal to f of x, you substitute negative 1 by 2, you will get the ordinate value or the y value also, right? So from this you get 3 by 4. So of course it is going from 3 by 4 to infinity, right? Correct. But if you don't want to apply this, just apply this negative b by 2a. It is negative 1 by 2 into 1. And now if you find the this value, the y value, it will negative d by 4a, which is negative b square minus 4ac by 4a, which is equal to negative 1 minus 4 into 1 into 4 into 1 into 1 divided by quantity 4 into 1. So you will get 3 by 4, right? And that's what I have written over here. So these are two methods whichever you are comfortable with, you can apply. But I prefer calculus method because it teaches us many things, right? So let's see this question also. So it is an downward facing parabola, correct? So it will have this maxima. So you can apply again negative b by 2a and negative d by 4a. So this is now maxima. So when I will use the derivative method, you have to solve using this method, right? Whatever method you are comfortable. It is negative 2x, negative 2 is equal to 0. So you get x is equal to negative 1. You substitute it back. You get y is equal to negative, it will negative 1 plus 2 plus 3. So it will be equal to 4. So hence y belongs to negative infinity to 4, right? Correct? Okay. And one more thing, if you apply this also, you will get the same result. It is, let me show you also. Let me show. But you have to try on your own, okay? So negative b by 2a. So it will be negative 2 by 2 times negative 1, which is equal to negative 1 and negative, yeah, now it's correct. Now it's okay. I mean, so negative d by 4a. So it will be equal to negative of what is b square? B square is 4. 4 minus, it will become plus. So 4 plus this quantity 12 plus 12 by 4 times negative 1. What it will be equal to? It will be equal to plus 4, right? So this is what I have written over here. So it also goes from negative infinity to positive 4, correct? Okay. Now this is an interesting question. Let me tell you. So this is also an quadratic expression, but in this case we are given some values. So basically we have to find the maxima. I mean, we have to find the range in this domain. So basically this is the curve, okay? So in this case what we do is that we find the values of the function at these 2 points first of all. So we will find f at negative 3, f at negative 2, right? We find at this value and at this value, and we find the value of function at negative b by 2a, right? Provided that negative b by 2a is belonging to x. We need to check for this statement. So first of all, let's check for negative b by 2a. So negative b by 2a, it will be negative 2 by 2 times 1, which is negative 1. So of course it is not belonging to this domain. So of course we don't need to check this one now. But why we need to check this? Well, let me tell you. So suppose if the function, let me tell you over here. So suppose if there was a range, I mean there was a domain, so from this to this, right? Suppose this was our this is negative 1, right? Suppose this was negative 2 and this was suppose positive 3. Let's assume this, okay? So when you find the range from this expression to this expression, so you can clearly see that the minimum value of this function is over here and maximum is over here, correct? So that is why if this point lies in this domain, in the given domain, so you need to check this, because in that case the range will be from here till here, right? Correct? All the values from here till here. But suppose in our case it is like negative 1 is over here, negative 3 over here, and negative 2 over here, right? Correct? So in this case we don't need to check anything because it is an decreasing function, right? It is an strictly increasing, I mean it is an strictly decreasing function from in this domain, I mean, right? But in this case it is an strictly decreasing from here till here, then it is an strictly increasing function, right? So that is why over here we need to check this value, right? Because we know that it is not a monotonic function. It is a non-monotonic function. It is first of all decreasing, then it is an increasing function. So that is why there will come a point where it will have a maxima or minima, right? It depends, right? So that is why, let me explain you now the question. So of course, yeah, let me change the color. Yeah, so over here, let me tell you, yeah, let me draw the graph again. So this is -1, this is -2, this is -3. Of course, this is at function -2, and this. So we need to just calculate this, right? So f at -3, what it will be equal to? Well, when it's to -3, you will get -3 square plus 2 times -3 plus 4, correct? Right? So you get 9 times, 9 minus 6 plus 4. So you get 13 minus 6, which is equal to 7, right? And what is the function at -2? Let's calculate that also. So function at -2 is equal to -2 square plus 2 times -2 plus 4, which is equal to what? Which is equal to 4 minus 4 plus 4, which is equal to what? 4. Hence, we have the value as 4 to 7, right? This is the range in this case, right? Now let's take this example. So again, its graph looks like this, and we have to first of all calculate f of -1. No, first of all you have to calculate negative b by 2a. So negative b by 2a is equal to -1 by 2 times 1, which is equal to -1 by 2. And -1 by 2 lies in this domain. Hence, this is, let me draw it with some other color. So this is -1 by 2, right? Some value. This is -1 and this is +1, correct? Right? Of course, I'm not drawing the axis in this case. Just understand this is just the abscissa values, right? This is not the y values, okay? So in this case, we can say that the point of minima is over here. So of course, the range will go from here till here, right? Now I don't know that which value is higher. Let me see that. So f at -1 is equal to what? 2 times -1 whole square plus x plus -1 plus 1, right? So this is equal to what? This is equal to 2. F at 1 is equal to what? 2 times 1 square plus 2 plus 1 plus 1 plus 1, which is equal to 4, right? Correct? And what is the value at -1 by 2? Well, it is equal to, you just substitute it over there, 2 into -1 by 2 square plus -1 by 2 plus 1. So you get 2 times 1 by 4, -1 by 2 plus 1. So it is 1 by 2 minus 1 by 2 plus 1. So it is equal to 1, right? Correct? Hence, y belongs to 1 to 4 in this domain. So it is going from this is the value. Okay? So it is going from 1 to 4, correct? This and this, right? Correct? Okay, so now let's see this question. This is the last question, and then we will see a summary so that you can understand everything in a better way. So what we do in such kind of question are quadratic by quadratic. So we basically bring this expression over here. X square plus x plus 1 is equal to x square minus x plus 1, correct? So we have yx square plus yx plus y is equal to x square minus yx plus 1, right? So you have y minus 1 into x square plus y plus 1 into x plus y minus 1 is equal to 0, correct? Now we have a quadratic in x with coefficients as y minus 1, y plus 1 and y minus 1, correct? So we find the discriminant, it will be equal to b square, sorry, it is will be equal to b square minus 4ac, which is equal to y plus 1 whole square minus 4 times this a into c, right? Let me solve this, then I will tell you something. Y square plus 2y plus 1 minus what is this expression? This will be 4 times y square minus 2y plus 1, correct? So you get y square plus 3y plus 2y plus 2y plus 1 minus 4y square plus 8y plus minus 4, correct? So it is negative 3y square plus 10y minus 3. And can we further factorize it? Yeah, of course we can. So let me write it. Sorry, it will be negative 3y square, right? So it is negative 3y square plus 9y plus y minus 3, correct? So it is, we take negative 3y common, so we have y minus 3 plus y minus 3. So we have y minus 3 common and 3y minus 1, correct? This, okay? Or you can say it like this also. You have taken negative 3y as common over here, and you have this expression. So you have this actually, sorry, yeah, this 1 minus 3y, sorry, yeah, okay. So just see this expression, right? So is it fine? Just check it once. So this expression y square plus this expression and then this, right? And then we got this expression, right? And then we had this expression, then we took y minus 3 as common. And of course, now the thing over is that if this is equal to discriminant, if x belongs to real number, then it implies that discriminant will have to be always greater than equal to 0, correct? Of course, if x is belong to real number, then how can discriminant be less than 0? Because on solving, x will be dependent upon y. Because of course, if discriminant will be non-zero, I mean if it will be less than 0, then in that case x won't be a real number, right? Because again, in that case the solution will be complex numbers, right? Hence we have y minus 3 into 1 minus 3y is less than equal to 0, sorry, is greater than equal to 0, correct? Hence 3y minus 1, y minus 3 less than equal to 0, hence y belongs to 1 by 3 to 3. That is a domain, and that is how you find the domain in this case, right? So if I summarize everything, we know that y is equal to f of x. So from this, you will go from y is equal to f of x to x is equal to g of y, and then you will apply the same concept as you applied in domain, right? And that is how you will solve maximum of your problems, right? Correct? Okay. And in case of sine function, you will apply like this, and in cos also you can apply the same, and there are other methods also which you can apply. Of course, you should not be dependent upon only one method which I am telling or anyone else is telling. You should try to make your own methods, right? So it is totally okay. You should try to manipulate things. You should try to find new things. Of course, it is really interesting. Then it makes things very interesting, right? And personally, I do the same thing, right? Okay. So this is also done, right? And this is also done, and this also. And yeah, correct, everything is done over here. So you should note all this, right? And if you want, I will provide this PDF also if you want. Okay, so yeah, that is all. So if you did enjoy this video, then please do like, share and subscribe to my channel. Bye bye, take care.